Hello guys, so today we're going to be going over trigonometric ratios. Now this is usually known as SOHCAHTOA, and that's actually three different acronyms. Before we go ahead and go over what SOHCAHTOA is, we have to first learn about three different types of sides. So let's go over the first one. The first one is going to be the hypotenuse, and the hypotenuse is something that we have seen before. The hypotenuse is the longest side of the triangle, and it is also the side that is opposite to the 90-degree angle. So in this case, if you remember, the 90-degree angle is denoted by the square. So this red square that we have on the triangle, that's the 90-degree angle. So in other words, angle C. And now what is opposite to that angle? Well, that is going to be 41. So in this case, 41, or the side length 41 is the side that is opposite to angle C, or it's opposite to the 90-degree angle. So what is the hypotenuse for the second example, the one on the bottom? So we have the 90-degree angle here. This is going to be the opposite side. So therefore, this is going to be my hypotenuse. Let's go over the last one. So the last one, which one is my hypotenuse? Is it going to be 14, 48, or 50? If you answered 50, you are correct. 50 is going to be my hypotenuse because that's the largest side, and also because it's the one that's opposite to the 90-degree angle. So 50 is my hypotenuse. Now, this is actually the easiest one out of the three. The second one is known as the opposite. So the opposite is not so simple. In this case, notice that we are being asked the opposite side of angle A. So in other words, we're only focusing on angle A. So, but I also want you to keep in mind that although I only wrote angle A triangle is composed of three different angles. So triangle means three angles. In this case, we're focusing on one of them, but you may be required to solve for more than one angle. So for now, just keep that in mind. But let's go over this example. So what is opposite to angle A? So first of all, angle A, that's going to be this one, is made up of these two sides, right? It's made up of angle side 40 and side 41. So 41 and 40, those two side lengths make up angle A. So the one that is opposite to angle A is the one that is not being used. So that's going to be 9. 9 is my opposite. Okay, and then from the previous three examples, we know that this one is going to be my what? That's going to be my hypotenuse, right? Because that's my longest side. We are not being asked to find the hypotenuse, but I want you to keep that in mind. So now the second one, the one at the bottom, we're being asked again to find the opposite of A. So A is there. Now the two side lengths that make up A are 12 and 37. So the angle that is, not the angle, the side length that's opposite to angle A is 35. So 35 is going to be my opposite. Opposite, sorry about the keyboard, it keeps on appearing. Opposite. And then my last problem, we have angle A here. So therefore my opposite is going to be 14. Okay, so now let's go over the last one. The last one is going to be known as the adjacent side. So let's go over how we started off with the previous one. So we're being asked to find the adjacent side of angle A. So angle A is made up of two different sides, right? It's made up of side 40, and it's also made up of side 41. But remember, side 41 is the hypotenuse. So side 41 cannot be the adjacent. And now angle, I mean not angle, but side 9 is the what? What did we learn that 9 is to angle A? So 9 is actually the opposite side of angle A. So that cannot be the adjacent either. So the only side length that we have left is 40. So 40 is actually my adjacent, or in other words, it is also known as the side length next to the angle. So next to the angle A, or one of the side lengths that make up angle A, is going to be 40, and that's the adjacent because the other one is the hypotenuse. So let's look at the second one. So we have angle A, and it is composed of these two sides, 37, and the second side is going to be 12. Sorry about the keyboard again. The second side is going to be 12, and that makes up angle A. Now, which one of those two is the adjacent? So it cannot be 35 because that's opposite, and it cannot be 37 because this is the hypotenuse. So my adjacent is going to be 12. So if someone were to ask you what is the side adjacent to angle A, that will be 12. And let's go over our last example. Try to do it by yourself. So what is the adjacent of angle A? This is going to be my angle A. Which one is the adjacent side? If you answered 48, you are correct. It's not 50 because 50 is the hypotenuse. It has to be 48. So 48 is the adjacent. And 14 would be the opposite. So now this is going to help us to figure out what SOHCAHTOA is. So actually, SOHCAHTOA is an acronym for the three different trigonometric ratios that we're going to learn. The first one is sine. So the first part of it is going to be this one. So SO, or SOH, really means sine of A is equal to opposite over hypotenuse. And this is going to be a fraction. So a ratio is a fraction. So it's a fraction. Sine of A is a fraction where you put the opposite side over the hypotenuse. Now the second one, cosine, if you notice it has the three following letters, C-A-H. So what do you expect is going to be on top? So if you notice on the previous one, so the O goes on top. So what do you think is going to go on top for this case, for cosine? And now we write COS, but we say it as cosine. Cos is just an abbreviation. So cosine, you write it as COS, but we say it cosine. So this ratio is going to be adjacent. And let's make that in capital. Over, what do you think is going to go on the bottom? The hypotenuse. Right? Because we have CAH, which is cosine of A is equal to adjacent over hypotenuse. And the last one is tangent. Now, what is O? Well, in this case, O is going to be the opposite. O is the opposite, and A is going to be the adjacent. So the resulting ratio is opposite over adjacent. So now let's go over some quick examples. So the first one that we have here, it's asking us for sine of A. So sine of A, first of all, let's write down the, let's make it in color coded. So it's going to be the ratio. So it's going to be opposite, whoa, what's going on? So let's write it again. Opposite over hypotenuse. So therefore, well, first of all, what's opposite to A? So the one that's opposite is going to be 27. So it's going to be my opposite. And then what's my hypotenuse? It's going to be 45. I'm going to put HIP. And therefore, the last one is going to be my adjacent. But in this case, we don't really need to know adjacent because all they're asking us to do is sine of A. So this is going to be sine of A is equal to opposite, which is 27, over 45. And now 27 over 45, you can actually simplify that, right? So 27 there and 45 are both divisible by 9, so it's going to be 3 over 5. So my answer is, oh, that keyboard keeps on appearing, sine of A is equal to 3 over 5. Now let's do cosine of A. So first of all, let's write down the equation. So cosine of A is equal to adjacent over hypotenuse. So let's go ahead and identify each one. So now, if you look at the top, what is going to be 27? So 27 is going to be what to angle A? Well, that's actually going to be my opposite, right? So that's going to be my opposite, and then 45 is going to be my hypotenuse because the one that's opposite to the 90-degree angle. Therefore, my last one is going to be the adjacent. So in this case, my ratio is going to become cosine of A is equal to, which one should go first, 36 or 45? Well, 36, right? Because it's adjacent on top, and then 45. And now these two are actually both divisible by 9 as well. So every time you can, make sure that you do simplify. So cosine is equal to 36 divided by 9, that's 4 over 5. And now the last one, tangent of A. Well, tangent of A is actually opposite over adjacent. So let's go ahead and give the ratio. So tan of A is equal to, well, this is going to be my angle A, so this is going to be my opposite, and we've done this twice already, so this is going to be my hypotenuse, and the last one is going to be my adjacent here on the bottom, adjacent. So now the ratios should be 27 over 36. They're both divisible by 9. So that's going to be 3 over 4. Okay, so like I said, I'm going to make another video with more concrete examples. The examples are going to be these, and as you can notice, they're going to be different types of triangles. So make sure you guys go ahead and watch that video as well.